Alright, welcome back for Explain 3 Modelings with Square Root Functions. We're still in lesson 10.2. Here it's asking us to read parts A and B and complete the Your Turn that's in your packet. So first thing, let's do a practice problem. It says a car with good tires is on a dry road. The speed in miles per hour from which the car can stop in any given distance d in feet is given as s of d, or equals square root of 96 times d. Use the distance for 20, 40, 60, 80, 100. So here we see there's 20, 40, 60, 80, 100. So on our calculators we could calculate each one of these out to be 96 times 20, square root that, 96 times 40, square root that, and essentially we're doing that for each one of these values. So take some time and do those calculations. And if you took the time to do those calculations, as I asked, that would be about 43.8, 61.9, 75.8, 87.6, and about 97.9. So on here I'll go ahead and graph those. That would be 20. That's kind of nice to actually type in or write in some of the values that are missing. And 10, 20, 30, 40, 50, 70, 80, 90. Alright, so that would be about 20. I think that would be about there. 40. Maybe about right there. And 60, 75. And 80, 87. And then 97, 9. So you can kind of see, oh, that last point kind of went away. Try and bring it back. You can kind of see that that kind of goes up. Oh. So the next thing they ask us to do is we plot. Yay. We're going to find the first interval. So here you notice from 40 to 20, we're using those first 2 points. So that would be 61.9 and 43.8. We're going to go ahead and work that out and figure out what the numerator and denominator are. So take some time to calculate that out. And that would be about 18.1. 40 take away 20 would be about 20. And then if I divided this out, that would be about 0.905. Then if I took the last two numbers, last interval, 100 take away 80, so 97.9, which is paired with the 100, and 87.6, that's paired with the 80. And we work that out. Go ahead and pause here and take some time to calculate that. And that would be for the top portion about 10.3. 100 take away 80 would be 20. And if I divide this out, that would be about 0.515. The next thing it asks us to do is to go ahead and find the average rate of change is blank for the last interval. The average rate of change represents the increase in blank with each additional blank. As the available distance, stopping distance increases, the additional increase in speed per foot of stopping distance is blank. So let's fill in some of these blank spots that we see here. You can see that your last interval was about 0.5 and some change versus 0.9. In fact, you can kind of see that the average rate of change is actually much less for the last interval. The average rate of change represents the increase in the, well, what was S standing for? For speed, right? So for speed, with each additional distance in feet. So distance in feet. As the available stopping distance increases, the additional increase in speed per foot of stopping distance, well, as we saw that it was less, so do you think it's increasing if it's less or decreasing? Decreasing, because it's becoming less. Here it was 0.9 and here is 0.5. 0.5 is obviously less than 0.9. Let's continue on with another problem here. So here's another one. It shows, use your calculator to evaluate the model and connect the indicated points, and then calculate the average rates of change over the first and last intervals. So here we have a farmer is trying to determine how much fencing they'll need to buy. They give this function, which I know is not really easy for you to see on the screen, so I'm going to write that out. F of A equals 4 times A, the square root of A minus 6. And our intervals are going to be 20 through 100 every 20 feet. So that would be 20, 40, 60, 80, 100. So let's do some calculations so we can plot some of these points out. So those points would be about 11.8, 19.2, 24.9, 29.7, and about 34. So we'll plot some of those points out. It's just easier to write some of the in-between numbers on our graph. And that would be halfway between 0 and 8 would be 4, 8, 12, 16, 20, 24, 28, 32, and 36. So we'll go ahead and plot some of these points out. 11, 20, 11 should be somewhere about there. 40, 19.2, and 60, 24, and 80, 29, and last but not least, oh sorry, that last one kind of went away there, 134. So that'd be about right there. So that would be the plot of our points. On this next value, we're going to go ahead and calculate the average rate of change over the first and last interval. So here I'm going to copy down some of the values I got for my first interval and my last interval. So that would be 2040, and that was about 11.8 and 19.2. For our last interval that we got, that would be about 80, 100, and the partners for that were about 29.7 and 34. So we're going to find our rate of change. So here we have we have about 20, 11.8, and 40, 19.2. So for my rate of change, I'm going to use my x values on the bottom here, 40, take away 20, and we're going to go ahead and subtract the partners to each of those values. And we're going to do the same thing for the last interval. So that's 80 partnered with 29.7 and 134, so that'd be 100. Our x values here. 100 take away 80. And our y values, 34 take away 29.7. So take some time to work out each of these and find out what the interval is, and we'll go ahead and fill out the sentence starter. So that would be about 7.4 and 20. If I divided that out, that would be about 0.37. If I subtracted this one out, that would be about 4.3. and about 20. We divide that out, that would be about 0.215. So it says the average rate of change is less than or more than for the last interval. As we can see, the first interval is about 0.37, whereas the last interval is a little less. So a little less, and the average rate of change represents the increase in, well, we were comparing the area and the length of fencing. So we're comparing the area with each additional length of fencing, and that was fencing in feet. Just like it says here, it says stop, do the problems in the packet. So there is a problem, the your turn number 8. Go ahead and take some time to do that right now.